I want to break it down so that we can understand why we do things the way we do in SQL. All right. So just a second, then I want to get this humming sound out of my background, and then we would just start. All right. So let's start now. I'm just going to share my screen. What you're going to see on my screen is just a regular Excel table. And what is it? It's just a report, all right? Most times when we work at work, anywhere we are, we usually generate data. So sometimes the data is generated inside of Excel, sometimes it's generated inside of a proprietary software, sometimes it's generated inside an app or something. But we just know that we generate data. So we have data that we generate for sales or for whatever. All right. So what happens is we just put all of them. Usually Excel is the culprit because that's what most people use in their offices. So your boss tells you, please, I want you to make a report of all the people who were in the office today, attendance report. So bam, Excel just comes to the rescue. You just start, throwing the values inside there. So today's date, then the staff name, staff ID number, time in, time out, all of those things, just capture it. So usually what we do is we just capture data, But then when we capture data, what I've discovered is that many of the data we capture, we don't even intend to process it because the way we capture it just makes it look very awkward, makes it look unprocessable. Like I could show you some of the reports that I have, some of my clients who I work for, all right, have, so sometimes some clients call you, okay, so come and do data consulting for us, a BI consultant, and set up our BI systems, stuff like that. And then by the time you get there, they will tell you, yeah, we have this report, we have this report, we have this report. And when they forward those reports to you, boy, you're going to want to cry because the form, the content, everything is just work. So there are some reports that the way they were collected, it was very glaring that the people that were collecting it did not intend to process it at all. Because when you see those kind of reports, one of the things you would notice is that those reports have plenty of issues. Either they have missing values or they have some values that will never ever, as in the person can never ever have it complete. For example, okay, so if you're collecting attendance data, I can assure you most times that the data for timeouts when people leave the office would most times not be complete. The reason is simple because some people are living in a hurry. Some people, when they came in the morning, they just, maybe they're marketers or something. So they came in the morning, they signed in, and then they left for marketing or whatever with the hope that they will come back to the office. And but for one reason or the other, they did not come back to the office. They went home from there, stuff like that. So you would notice from experience that most times the clock outside of things is never complete. All right. So those are the kind of things that you get to see on the field. But then the question you want to ask yourself is this: all this data we are just collecting, what do we intend to do with it? So this report you see here, and I'm going to make this available in our Google Drive. I'll send you the link for those of you who don't have it. I think every old person here has the Google Drive link. So, but this report that you see here is just basically about, okay, so a company just decided, okay, let's put together our sales report. So if you look at this, this is the date of the transaction. This is the sales rep that sold it. This is the sales rep's name, person's phone number, the branch where the person is, and then this is the product that the person sold, the product ID, the product name, and then this is the customer that they sold it to. All right, so that's the customer ID, and this is the customer name, and this is the customer region. All right, and this is the number of units the customer was sold to. This is the unit price. This is the total revenue. It can even be longer than this. You know, there's some that just keep going. For example, they might even tell you things like whether it was a promo or not, was there a discount or not, you know, stuff like that. Even the invoice number of this product that also the customer is even captured. So you could easily have 50 columns on just this piece of data. Now, you see the way this data is. You can process this data in any system. You can process it in Excel, you can process it in Power BI, SQL, or whatever, the way it is right now. And it works. It's going to work. But then, what we are going to have to deal with is what we call redundancy. And redundancy is the enemy of every analyst. What is redundancy? Redundancy is basically having excess data than what you're supposed to have due to repetitions. So if you look at this table, if I even want to analyze this table inside of Excel, you would notice something that, look at this person. This is the first sales rep. This is what they sold, all right? This is the person's phone number. This is the branch, you know. Now, if I want to run an analysis, you would notice that for Excel to effectively analyze this table, it will have to analyze like this. Okay, Cameron Diaz, okay, another Cameron Diaz, another Cameron Diaz, another, and it will have to analyze all of these repetitions. So imagine that I run a VLOOKUP on this function. Let's say I have even 1 million rows or 1 point something million rows, all right? Because of the amount of repetition on this document, it will slow down the performance of my reporting, irrespective of the tool I'm using, whether I'm using Excel, I'm using SQL or whatever. So how do we break up the redundancies that are available in this database? The first thing that we want to do to deal with the redundancies that are available in this data is we want to remove all the repetitions and create a lookup table or sets of lookup tables so that when the an analytical tool, whether Excel, Power BI, or SQL or whatever, has to analyze, once it comes here and says, okay, this is Cameron Diaz, it doesn't need to look in here to know the number or the name. In fact, it doesn't have to have these details here, but the branch. It will just go straight to the lookup table and pick every other value that it wants to pick. So the main reason why we have to break down this table, all right, into smaller chunks is to reduce redundancy due to all these duplicates. This process of breaking down a table or a transaction table or whatever that you have into smaller chunks is what you call denormalization. Sorry, normalization. All right. So why is it called normalization? The reason is simple. You're trying to make the table normal. All right. So somebody will ask me, is this table abnormal? Yes, it's abnormal because there are a lot of repetitions there that should not be there. All right. So how do we convert a table from abnormal to normal? Now, you know, just like you have in real life, normality has levels. All right. So there are like 4 3 to 6 different levels of normality in data management, all right, database management and analytics. There is the first normal form, there is the second normal form, and there's the third normal form. Well, some people go up to 6 normal forms, but I'm not going to bug you with all of those normal forms and all of that, all the details. You can always Google it and read. But I'm just going to demonstrate the end result, what you're going to get when you have passed through all the first, second, third levels of normality, and you have worked on that on the table. All right. But if you are very curious, you can, like I said, Google it and you'll be glad you did. So what do we do when we are faced with a table like this? Very, very simple. The first thing we are going to do is, let me show you if I want to normalize this table. First thing I'm going to do, so let me duplicate this table, all right? So I'm just going to duplicate this table. Sorry. Okay, so now, so I have a copy of this table here, all right? Remember that I told you that the whole essence of normalization is to make a table efficient by removing all these unnecessary duplicates. So when we pass a document through the first normal form, there is a level of duplication that the first normal form takes away. Then we'll get to the second normal form. It tackles another set of duplication and some inefficiencies. We get to the third normal form, you know, like that. So let me show you how those normalities work, all right? So this is it. Now, let's look at this table here, okay? So if you look at this, you would notice that we can pick out the entities that the data in this table tells us about, all right? This transaction table that we have here tells us a story about entities of various, if you like, people. The first entity that this table tells us about is the sales rep entity. Who has a sales rep ID? This is his phone number and is attached to a branch. So this is the first entity that this table tells us about. The second entity that this table tells us about are the products that we have, obviously. So there are products like rice, semolina, wheat, and all that, who have product ID. So this is entity 1, this is entity 2. There is a third entity that this table is telling us about, the customer who, you know, has an ID, a name, and a particular region. Now, these entities that, you know, we have here are just 3. So these are details about what the entities did, all right? So because these are just details about what the entities did, things like how many units they bought and all of that, we do not classify them, all right, as entities, but they are just descriptors of what the entities did. So for each of these entities, we are going to create a new table for each of them. So we're going to create a table, all right, for the sales entity. Then we are going to duplicate this table, create another table for the customer entity. And then, oh, sorry, we should create one for products. So let's create one for products. So this table belongs to the product entity. Now I'm using that word very carefully, entity, because I'll show you how it plays out and when we tie it all up. Okay, so let's begin with normalizing this sales transaction, all right, for the sales entity. Because we are only interested in the sales entity, what happens is that we have to knock off all the other entities and all the other transaction details that relate to other entities, all right? For this table. So I really don't know why this thing is doing this. So pardon the slowness of the laptop. All right. So I'm just going to delete this. So right now, what we have is the sales entity, things pertaining to the sales entity. But remember that this sales entity has a lot of duplicates, and that's even the major reason why we are trying to normalize it, because it's not normal to have duplicates in your data. All right. So let's run a small operation here. Remember, I'm just doing this with Excel, but you can do this with any tool. You can do this with Python, you can do this with SQL, you can do this with anything at all, all right? But I'm just using Excel so that it can show how the whole thing works, all right? So now, I'm going to go to data, all right? And then from this data menu, I'm going to select remove duplicates. Okay, so let me close some of these apps that are here and see whether it will help my system process faster. Okay, all right, so now from the data ribbon, you would see this stuff here, remove duplicates. So I'm just going to click on it, and then it's going to bring out a pop-up for me, or a dialog box, if you like. And then the dialog box, what it's going to ask me is, I have 4 columns here, and my data has headers, right? I want to remove all the duplicate values in all the 4 columns. So what I'm going to do, I'm just going to click OK. And so what you'd see now is you can see the number of duplicates that were found and removed. So now the 15 unique values remain. So actually, this company had just 15 salespeople, all right? But because they had a lot of transactions, so you saw a lot of duplicates. Now, these duplicates were making the whole data inefficient, so we've removed it. So great, we have a sales table ready. Now, the second entity we have to work on is the product entity, all right? So as usual, we're going to just delete everything that does not relate to the product entity and leave just the, yeah. So this is just for the product entity. As usual, we're going to remove all the duplicates because that's what the normalization really does. That's one of the main things it does. It tries to remove redundancy that comes from all the duplicate things that you'll see in your data. All right, so I'm just going to click OK. And yeah, it removed it and 12 unique values remain. So actually, the company deals on 12 products, but there were a lot of duplications in the data. So we have our product table ready. Now, this third one is the customer entity, and we have to, as usual, remove everything that does not pertain to the customer entity. Remove all of this. So, as usual, we're going to run our duplicates, remove them, and okay, so we had just 8 customers, but because they bought a lot of things from us, then we had a lot of those duplicates. So as you can see right now, we have our sales table for the sales entity. We have our products for the product entity, and we have customer for the customer entity. All right. So these 1, 2, 3 are like the entities that we have. Okay. So now, if you go back to the original table where they came from, remember that our task here right now is now to ensure that all the unnecessary duplications have been taken care of. So what we are going to do in this original table is that we're going to delete everywhere we have duplications, like this now, sales rep, phone number, and all of this. And we'll just leave out this unique ID so that it can serve as a pointer to the sales entity table, so that When Excel is processing this and it just sees this, it just knows, oh, okay, cool. I know you're talking about this customer who has all these details. So instead of, having all this baggage, let's just deal with that. So that's what happens here. So I'm going to remove this. All right, 1, 2, 3, because they are already captured in the sales table, this sales entity table. And then I'm going to delete that and leave just the unique ID. Again, I'm going to do the same thing for products. Since we have all the details of products, it means that we are able to just delete this and leave only the product ID column, which is unique, and it can key into this product table here to tell us, every other thing we need to know about the product. So I'm going to remove this. And same thing for customer, I'm going to remove this too and just leave just this to serve as the pointer to the what do you call it now? The customer table. So if you notice something, you'll notice that we have removed a lot of garbage that would have slowed us down during processing. All right. So now, what we have done, all right, is what we call normalization. I don't know why I keep saying denormalization. And so this table that we have here, all right, this transactions table that has everything that happened in here is what we call the transactions table. All right. Or some people prefer to call it the facts table. So facts table or transactions table, any name you call it is fine. But basically what this table is telling you is all the things that happened, all right? Everything that happened to the entities. That's just what this table tells. That's why it's called facts. Facts in the sense that these are the things that happened, all right? Some people prefer to call it transactions table. These are the transactions the entities did or that pertain to the entities. So that's why they call this facts table. But all these other entity tables, all right, that we have here, all these other entity tables that we have here are called dimension tables, all right? Dimension tables. So why do they call them dimension tables? Very simple. Sorry, they call them dimension tables because they give you the dimensions of what happened, yeah. Okay, so there's a question in the chat. It says, so the facts table needs to have information from all other table. Exactly. That's the way it works. So the fact table will have information. This very fact table will retain these connectors that connect it to the dimension tables. And you see these connectors that are unique connectors. These unique connectors are called primary keys. All right. So actually, let me not that's not very correct. If you allow me, that's let me delete that. Okay. Now these unique numbers here, all right, like this one now here is called, all these unique numbers here are what you call primary keys. Okay, so like this one is a primary key. Then when you go to products, this one here is the primary key. And for customer here, this customer ID is the primary key. Why is this called the primary key? The primary key is always a unique identifier. Unique. which means that no other person or no other person here in that entity table has that number. Now, you see how I have White Rock here. We can have White Rock Limited, and there's another customer who is White Rock PLC. Now, in fact, for those of you who attended some very, very heavy schools that had a lot of people, like me now, I had somebody who was bearing my name and my surname. If they had said, let's use your names as primary key, I would have been in trouble because every time the database of our school results system will be throwing either one of us results out. But because we had unique matric numbers, like unique registration IDs, they knew that there is one Onyeka Ogochukwu, is ACC 2001-041. The second Onyeka Ogochukwu is this so and so and so and so, you know, like that. So because of that unique identifier, the database did not make any mistakes at all to think, okay, there are more than one person, so let's knock off the duplicates. No, it never happened. So that's why we always try to maintain a primary key that's made up of unique identifiers. But there are some times when it's impossible to have unique identifiers. Well, sometimes. So you have to combine maybe the ID and the name to form the primary key. In that scenario, when you combine two things, all right, to form the primary key, you call that kind of primary key a composite key, all right? So that's what happens. So you can have COO8 bunkmates LLC as the primary key. And that means we are trying to combine two features here in that table to be able to arrive at the key. But usually, most times, what we discover is that just one unique key it works, just one identifier. Okay, so now you see this customer ID, you see it here, all right? Whenever you reference a primary key from the dimensions table in a facts table, you call it, just a second. So whenever you reference a primary key in a transactions table, a facts table, that key automatically becomes what you call a foreign key. So while the customer ID in the transactions table is a foreign key, in the customer dimension table, this one is a primary key. It's one of the keys that drives the table, all right, in the database. So that's the difference. When a primary key shows up inside of a transactions table or a facts table, then we say that that has become a foreign key, all right? So that's basically the concept of normalization and keys. Do we have any questions at this point? Because I'm going to take it a notch higher from here. Any questions? Okay. Does anyone want to ask a question?
Hello,
I can.
please, can you,
yes.
Can you go back on the foreign key again? You said when primary key shows inside fact table, you have foreign key. Please, can you go back again and explain?
Okay, great. So, like I told you, a primary key is a unique identifier that exists inside a dimension table, all right? And a dimension table is nothing but a table that talks about all the dimensions of an entity. You know, when you hear about dimensions, it's just talking about the various parts or the various aspects. So if I tell you what's the dimension of the room you're in, you're going to tell me maybe length, 10 square meters, width, 5 square meters height, maybe 25 meters or anything else, just okay, let me use 25 meters, not square meters here, because this is an area. So just 10 meters, 5 meters height, 25 meters. Now, all you're telling me are the dimensions of the entity called your room. All right. It's the same thing when I tell you, tell me the dimensions of the customer. You're going to tell me his name, his unique ID. You're going to tell me where he is, address, state, etc., all of that. So that's why they call this table a dimension table. Now, because of the principle of normality, every dimension table must, right, have a unique ID, So that unique ID that drives all of this, all these unique IDs, they are what you call the primary key, all right? So if you remember, for us to be able to connect this, it's just like doing a VLOOKUP in Excel, all right? The VLOOKUP must be driven on something. So that thing that we're using to create the lookup between the primary, between the transactions table and its dimensions table, all right? I'm sorry. Sorry. Is what we call now the foreign key. So you can see customer 001. When you're processing this thing now in Excel, Excel will just say, let me go to the customer table. And who is customer 001? Oh, white truck, Middle East Africa. There's their phone number, there's the address, etc., all the dimensions that have been given. So that's what it does. It tries to reduce the load on your dimension, on your transactions table or your facts table, if you like, so that you do not overload them with repetition. So that's basically what it does. So that's your foreign key. Your foreign key is it's your normal primary key, but appearing inside of the facts table. So.
Oh, thank you. I think I got it better.
Okay, cool. Okay, so so from here, now we can proceed. So let me just remove. I'm sorry, something is choking me. So let me make this sales rep. All right. And then I'll remove all these drawings. Okay. Remove all the markings that I did. Okay. All right. So I'm sorry. Okay. So I think there are no more. Okay. This is just this last one. Oh, plenty here. Okay. So why I'm deleting this is that I want to move this into another part of Excel. For those of you who are used to Excel, you know the part of Excel called Power Query. All right. But if you're not very used to Excel, I'm just going to show you what Power Query is in just a second. So this is it. Now, usually for people who do analysis in Excel, old Excel was a problem. Excel was not meant for big data before. And how will you know? By the time you go down to I just did control down, you will notice that the last row in Excel is 1,048,576, which means that Excel can only take 1,048,000 entries. All right. Now, imagine that I used to have a friend, I used to have a friend who was like head of data center in one of these telecoms companies. All right. So the boss would tell him, I wanted to run a utilization report for us. Now, utilization report is like a report on all the subscribers that they have to show how much they used in the last 5 years, sorry, 5 years, maybe the last 5 days or in the last week, maybe last 7 days or something, so that they can know, compare it week on week to know which customers are improving, whether there's a particular segment that is doing better than the other, whether there's particular state, just basically they just want to run analysis on those stuff. Now, a company like MTN has 170 million active lines. Excel can only take 1 million rows. So where would you put the remaining 169 million when you're analyzing them? Nowhere. All right. So it means that you cannot use Excel to run that kind of analysis, in quotes. So Excel began to lose market share because Python came, D3.js, all of them started coming with the promise that they can do any amount of rows. So Excel had to introduce something that can enable it to carry a heavy number of rows. All right. So I've used Power Query to do 10 million rows, I think. Now, I even saw somebody online that did 20 million rows, but the only problem, the only snag is that when it comes to Excel, if you the higher you need to, the higher number of rows you need to process, the more the processing power you need. So, like to process that 20 million rows, the guy that did that, I'm going to put the screenshot. He did a screenshot and put it up on our listing on LinkedIn. All right. So we'll have we'll have a couple of LinkedIn groups here and there, So he just put it up there to show that, man, I just did this right now. And it took him 3 minutes to upload and refresh that data. So, but his system specification was crazy. The RAM alone was 32 gig RAM. The processor speed was about 3 point something, I'd be almost 4 gigahertz processing power. Then the hard drive and all of that. So it was crazy. The specifications was crazy. If you want to get a laptop like that in current Nigerian rates, you probably are going to need like 2 to 3 million naira to get that kind of device. And because many people do not have that kind of funds to do that, what they would rather do is to use tools like Python, and all of that, which are not really resource intensive like Power Query. But Power Query makes things easy. So, but what I have shown you here is the first step in the whole normalization process. All right, that's the first step. Now, the next step will now be to connect, to connect the lookups, all right? So that when I'm analyzing this stuff, Excel knows that when you see this EM001, I'm talking about this sales rep EM001. So I need to create like a join in a relationship between this table and this table. I cannot do that relationship here. All right, I can't do that relationship here. So I'm going to go into that Power Pivot. Power Pivot is the data model side of Excel, all right? And I am going to do all my analysis and all my data modeling there. So again, what is data modeling? Data modeling is the process of building relationships between facts tables and dimension tables. That is all. Nothing more, nothing less. All right. So when you hear somebody say, I want to be a data model, I'm doing data modeling, or that, it's just bobo. It's nothing serious. It's just trying to create relationships between transactions table and facts table. So let's use Excel's Power Pivot tool to do that. Now, I will go to data, and then you can see this thing here, which says go to the Power Pivot window, all right? So when you, depending on the version of Excel you have, could be 365, could be, in fact, another way we could do this is I could activate the Power Pivot And let me just do that. Let me show you. Go to more options, then customize ribbon. Then from customize ribbon, I should see the power pivots. Let me see. Okay, let me put all so that I could see power pivots. Let me see where you are. Power pivots, where are you? Power pivots, where are you? PO. Okay, so apparently they have pulled it from Excel 2021. But if you're using like 2019, you'll still see that option of power pivots there, all right? So but I could always get it from this place. So let me just go to this place and click on this data model. Enable the data. This is added. Oh, I see. Sorry. I did not enable, I actually disabled the analysis toolbar because it was being a pain slowing down my Excel, so I just had to disable it. So let me go enable it. Now, I think it's a com added, right? Let me see. Ah, yeah, so this is it, power pivots. So let me enable it for now, and yeah, so it has opened up here. So my bad. They didn't pull it. It was it was me that disabled it. Okay, so now I could say I want to, let me just say manage. I'll just click on this. All right. And it will open the data model for me. But that's a very long route. I should just go straight. But I just want to show you that you can actually do it like this by saying, clicking on manage. All right. And this is actually why I disabled it, because it makes my system slow. Okay, so I think it's going to open right now. All right, so this is it. You would notice that the interface looks, it looks weird. It looks like it's not Excel, all right? But it's actually Excel, right? It's Excel. So it's still trying to come up. Still trying to come up. Okay, so cool. So now what we're going to do is we can bring in the data from anywhere. So you can bring in data from a database, you can bring in from a data service, you can bring it from any other source. It could come from like SQL, it can come from an Excel file or from a CSV file or whatever, all right? So when you just click on it, to tell it to import it like that, but that's not the fastest way to do it. So the fastest way to do it, let me just close it, is just click on the table that you want to do and then say the add to data model. So once you just click on this, it would ask you, my table has headers, all right? Now, okay, let me do something. I forgot to tell you, one of the practices as an analyst, you must know, especially when you're working with Excel, Power BI, or any of these Microsoft tools, all right, is that most times it's safer for you to convert whatever data you're analyzing into a table. I'm talking if you're working with Excel, Power BI, or what's other Microsoft tool that you have, Azure Analysis Services, yeah. Any of these things you're working with, you always want to convert the data you have into a table. So how do you convert the data into a table? Very simple. Just click on the data, go to insert, all right? And then from insert, click on, sorry, I just need to, yeah, sorry, I had to deal with that. Okay, so from insert, click on table, and then it would select the whole area your table is supposed to cover. You can just scroll down to make sure it actually gets to where your table ends, which usually is the case most times, unless there's a break in your table. But when you do that, you say your table has headers. So you just click OK because your table has headers. So now your data has become a table. Maybe next week, if we have time, I'm going to explain why this is very important and what is the difference between having this data saved as a table and just leaving it as a range like this, all right? So I'm going to come and rename this table. I'm going to call it transactions. So that way I sort this out, all right? So there's a question. We must have time, sir. Okay. Okay, yeah, we must have time. All right, so I'm going to do the same thing for this one. And I'm going to create the table. My table has headers. Yeah, so it becomes a table. I'm going to name this sales rep. All right, so sales rep. I'm going to do the same thing for this one. Insert table. And I'm going to name it as products. And the last one, I'm sorry, I'm going to do the same thing, insert table, and I'm going to call it customer, all right? Now, that way, remember initially it was showing table 1, table 2, table 3, table 4, and it could be very clumsy if you export your table like that into the data model. So now when we come to this data model and we say add to data model, you'll notice that Excel just carries that table like that, straight up, with the name and everything inside. So you can see, and it has put it inside the Power Pivot window. This Power Pivot is what enables Excel to run 20 million, 30 million rows. Without the Power Pivot, if you don't have that Power Pivot activated, Excel can only run 1,048 rows. But with the Power Pivot activated, Excel can run 10 million rows, 20 million rows, 30 million rows, depending on your system configuration. All right. So now we have added this to the data model. I will go back to my Excel window. You can see the Excel window is, I hope you can see the Power Pivot window. Let me share my whole screen so that it makes it straight up easier. So, so you can see the Power Pivot window here. Now, I will now go back to my original Excel table, click on the sales rep table and do the same thing, add to data model. It will carry the sales rep table and throw it inside of the data model. So you can see the sales rep is now here, all right? Now, I will do the same thing for the product table. I will add it to the data model. And this is the product table. And then I will do the same thing for the last table, which is the customer table, and add it to the data model. And all my tables are now here in the data model. So this is transactions, sales rep, product, customer. Now, if I want to manipulate this data here, it doesn't allow me to use the regular Excel functions. I'll just come here, add VLOOKUP, sum, and all that. No, I can't do that inside of the data model. Inside this data model, the only thing I'm allowed to use is called DAX, data analysis expressions, all right? So I hope we have time. We could look at DAX much later, all right? When we are done with all the heavy stuff we need to cover. Because I always see Excel like the baby of the analytics family. There are some other heavy analytics. Like when we talked about creating data pipelines some weeks back, it's really difficult doing that with Excel alone. So now Power BI has created something called data flows, but you need to subscribe and pay premium service for that. All right. So you need to have I think premium. Yeah, you need to have premium to be able to use data flows. And premium costs you 20 USD per month. I think, yeah, 20 USD per month. So imagine you have to do that for all the analysts in the office. Sometimes the price could be much. And that is why most times people have to default back to Python and R because they are free, they are open source, they don't cost you anything to use it. So you can use that to create your data pipelines and all that. So that's why, like I said, Excel is not like the first tool of choice when it comes to creating data pipelines, because sometimes, yeah, it could be a problem. So now I have all my data in here, all right? And the next thing I'm going to do is to now create the relationships. To create the relationships, I will activate the diagram view here. So now you will notice that what I have here are all the tables in diagram form. It's no more in data form where it was showing me the data that was there before. It's now showing it to me in the diagram form. So this is what I'm going to do. You see the transactions table that is like the table that contains everything. I'm going to pull it down here. I'm going to put this here, put this here, put this here. I could even do it like this, all right? Do it like this. If I had more tables, I would just surround all the dimensions table around the facts table. Now, will it not work if I left it the way it was before? It will work. But there's a particular reason why we do this. We put the transactions, we put the transactions table in the middle where, because it's like the center of attraction, right? That's where everything is. All the dimensions, everything about the dimensions and all that, they are contained in the facts table and all this stuff about the transaction, okay? And then we make the dimensions table surround the facts table. So the next thing I'm now going to do is to create the relationships. I'm going to tell Excel that you see this product ID here, which is the primary key here, and the product ID here. These two are related. So when you are analyzing, and what I'm doing now is to click and drag, all right? So I'm telling Excel, when you are analyzing, always know that there is a relationship between this product ID and this product ID. So if you want to get more information, you can go to the product table. And now you would see that when I did that click and drag, Excel created something here. You see this thing here is called the relationship detail, all right? It's telling me that the kind of relationship cardinality that exists here is one to many. So there can only be one product ID because in the product table, it has to be unique. The duplicates are not allowed. That's why you have one. One means that it's only one. There can only be one customer 001, all right? There can only be one customer 002, customer 003, like that, or product 001, product 002. But here in the transactions table, you can have it because somebody can buy it 10 times, 500 times, so you have many of it. So this is what you call cardinality, relationship cardinality, all right? So the relationship detail, or the relationship cardinality that exists here is one to many. This asterisk here is like an infinity sign to just say, okay, yeah, you can have as many as possible, all right? I will do the same thing for the sales rep ID. So I'm going to tell Excel that when you want to know more, if you're analyzing this transactions table and you want to know more about the sales rep who owns the IDs here, you can look it up in this sales table. So you can see there's another one to many relationship. Then you would see that I could do the same thing for customer ID here. So I'm going to tell Excel to always look up to this customer table for your details. So what we have here is called your data model. And this design in your data model, all right, is what we call the star schema. STAR, star. Okay, let me write it here. So it's called your star schema, all right? So star schema. Now, there are other kinds of schema that are available. There's one called Snowflake. There are a lot of other schema that are available, but these two are the most popular. Staff and Snowflake schema. Now, as we proceed into analyzing database and analyzing data generally, you'll get to see the difference between the two kind of schema, efficiency, how they work, and why we prefer one over the other, all of those information. So this is the end point of where your normalization takes you to. It takes you to that point where you have the relationships in your data showing in a data model. So is there any question? Some people also call this the ER diagram. Let me go back to Excel. Some people also call it the ER diagram. So, sorry, you must have heard this before, ER diagram. So what is this? It's just basically entity relationship diagram. So what it does is that it shows the relationships between all the entities that you capture data for in your organization. So that's what you see here. From the small data that we have here, the only entities that we have are sales rep, all of this. But you will notice that this is just a very simplistic example. A real entity relationship diagram can be crazy, can be crazy, very crazy, because this is just for the sales side of things. What are for purchases? What are for returns? What are for, all the other things that we do? So by the time you sit down and try to create the relationships around them, you see a lot of tables. You see, like, this customer table can have other smaller tables, explaining further things about, like, this customer region. You can have another one. You can have a table explaining the regions that make up this Middle East Africa. You can even have them broken down into countries. All of these are just to enable your data have the level of granularity that will enable anybody that wants to get any kind of data, just get it from the database. So that's why this is called the ER diagram. So when we do SQL, basically, in a nutshell, what we are trying to do in SQL is that we are trying to create a database. And what is a database? A database is just simply a collection of facts and transactions table. That's just what a database is. A collection of all the tables there. And that's why this thing that we have here is also called a database schema, because that's what our database looks like basically. So some people call it data model. Some will want to call it ER diagram. All right. And then some want to call it database schema. But database schema is actually more of like a design term that shows what kind of schema was used to design the database, whether it was star schema or that. All right. So that's basically what we do in SQL. In SQL, we create all of these tables that you see now. So this is where what Melody was doing last week would now begin to make sense to you, because what she was doing is to now use SQL to create all these things inside the database. SQL is actually structured query language to create all of this inside the database, all right? So that, based on this, you can now query the data. So, for example, you've created the table. Let me see. I think I have a database here. I think there should be a database in this. Let me see. Second, SQLite. Okay, yeah. So there's a database here. Let me use this database. Okay, yeah. So this database is like You can see the books, the customers, the employees, the order of books, order log, and then the order. So you can see this is like the transaction table that contains the orders. And you can see that there's an order ID, which is like the primary key. All right. That was, the main order that the customer did. Then there is the customer ID, which is coming from the customer table. So you can see that this is now a foreign key that's coming from here. Then there's the employee ID, the employee that sold it. Again, this is a foreign key that is coming from the employee table. Then you see the sales dates, and then you see comments. All right. So that's basically what happens in SQL. Nothing serious. It's just to take entity relationship diagrams that you have created before and use the language to implement it inside of a database. And that's it. So I hope you now see the linkages of what we were trying to do in Melody over the last 2 weeks and how it connects to your data processing. The whole reason for which we're doing what we're doing is because we want to increase the performance of our database so that it can be more responsive when we are trying to retrieve data for analysis. All right, so that's the whole reason behind the SQL gist. Okay, so I'm going to open up the floor for questions and contributions, and then we'll be wrapping up.